have been one of the first researchers since 1989.
Very correct.
One of the original to find some of these nuclear effects,
Right.
neutrons, tritium. Describe some of the first experiments you did at the Bhaba Atomic Research Center and what you found.
Well, we got interested in the topic on the 24th of March 1989 when we saw a little news item in the Times of India newspaper which talked about the press conference. Because of the 12-hour difference, the press conference took place on 23rd, but we got it on 24th. Already it was 24th there. So we were very excited that neutrons are being found in a simple electrolytic cell. At that point in time, I was the head of the neutron physics division in Bath. Naturally, we had all the equipment to measure it. So we were very excited. But more than me, I would give the credit to the director of the center, who at that time was Dr. Iyengar. He was also a very open-minded person, and he convened a meeting on the morning of 24th March, 10 a.m. So within a matter of 24 hours, he gathered around him people from many different divisions who he thought might be able to replicate. So he really enthused us that, hey, we should try and check it out, and if nuclear reactions can occur in the solid state, it's a fantastic thing. But as I said, what interested at that point is the nuclear signature. If they had only said excess heat without nuclear signature, we may not have got so excited, but being in the Bhaba Atomic Research Center, being involved in nuclear technology, that is what. And so people set up experiments with whatever materials they had in their labs. Now, very interestingly, when this news item came, on that day, I already had on my table a working cold fusion cell. Now, you'll be wondering how. That's the whole. We had imported what is known as a hydrogen generator from a company in Ireland, which happens to use palladium alloys in the form of a tube and electrolysis. So you understand, here was an electrolytic cell using palladium, but it was meant to produce hydrogen, pure hydrogen gas. And the way it works is this particular cell used palladium tubes. And during electrolysis, it was meant for hydrogen, remember. The purpose is to produce pure hydrogen separated from the oxygen. When you electrolyze, so the hydrogen would diffuse through the palladium, come out in the central tube. If you remember this, did you attend this talk by Jed Rothel this morning? He was talking about the palladium silver alloy. He was talking about Martin Fleischmann. This cell uses precisely that. People knew that palladium silver is the right composition, is the best for separating hydrogen for diffusion. So you understand, here we knew nothing about cold fusion, but we had purchased this, and we were in the process of converting it from hydrogen generator to deuterium. Our interest was not hydrogen, we wanted deuterium for our hot fusion experiments. So all we had to do was to take out the light water solution, put the heavy water electrolyte, bring the neutron detectors. Within a matter of 3 weeks, we had the first bursts of neutrons and tritium and so on. That's from our group. But we were lucky, just by chance. And it was the world's biggest cold fusion cell at that, perhaps even up to now. It had 16 tubes, that big, 300 centimeters squares. It could operate at 100 amperes. None of the cold fusion cells you will be talking about have operated at 100 amperes. So it was a commercial cell. And tomorrow I'll be presenting those results. We found neutrons. But our cell, this current started going up, we were ramping it up. At some point, the heat probably went up and the cell shut itself down because it had already a built-in safety device to shut it down if the temperature goes up. All that was built in. Temperature went up, maybe because of the current or maybe because of cold fusion, we don't know. But the important point is we got several neutron bursts. We had 2 neutron detectors and a third one far away as the background. What we call the foreground detectors saw the neutron burst, the background didn't show. All this gives confidence that. And then at the end of it, when this natural shutdown took place, we analyzed the heavy water, the electrolyte, to see if it has any tritium. And to our surprise, we had fantastic amount. And probably again, that's why Mike McCobre has invited me this time to present the BARC result. But this is only from my group. But we had 12 groups. 12 groups, you will see that day. And we presented our paper at the first international conference, ICCF18 in Salt Lake City. Martin Fleischmann was there. And at that time, we had 50 people. World's biggest group, world's biggest cell, one of the best results. It was very exciting. Now, imagine 12 groups independently setting up cells with whatever they had in the labs very quickly and run it, and lo and behold, most of them got neutrons, most of them got tritium. And one of the important observations at that time was almost everybody observed that the amount of tritium we produce is 1 million times more than the number of neutrons. Whereas if it had been hot fusion, you should have get an equal amount. So in cold fusion literature, this is what is called the branching ratio anomaly. We were among the first to discover this, and we presented these results in July 1989 at an international conference in Karlsruhe, Germany. So in terms of published papers, we were among the earliest to publish the production of neutrons, production of tritium, the branching ratio anomaly, and all that. So you asked me.
So you were getting positive results.
Absolutely
that there was
positive.
Nuclear effects.
Exactly.
Yet it was not like it should be in hot fusion.
Exactly. So we were excited that within a matter of few months we got good results, and as we went on, we published a report. It was the first 6-monthly progress report. BARC results in cold fusion. BARC April to September 1989, 6-monthly report. Around that same time, the US Department of Energy's, shall we say, report, the ERAB report, came out saying that cold fusion is all nonsense and it's a mistake and blah. There was an Indian gentleman who worked in Salt Lake City at the University of Utah. He visited India around November 1989. He had heard about the results. He came and visited us, and he carried back with him a draft copy of that report. The progress report, BARC study, it is called the report number BARC 1500, which is in Jed Rothwell's website. You can see that. And here was our report showing that cold fusion is real. Nuclear effects are true. 12 different groups, 50 authors. And the US Department of Energy is saying cold fusion is nonsense, nothing happens. And I remember EPRI, Electric Power Research Institute, Passel is here, he was that time the head in charge. They were going to fund SRI, $13 million. But suddenly when the US Department's report came, they started having cold fusion. Should we fund $13 million? But then they also got our report. They were confused. Is cold fusion real? You should ask Tom Passel for the story. He's right here. You can ask him about this. And they decided to do something. They said, listen, we have to go to BARC and check this out. So EPRI sent 2 of their scientists to BARC, talked to our director. They flew down to Bombay. They spent Christmas to New Year's 1989, 25th of December to 1st January, a whole week, 3 days, meeting the people who have presented, visiting the lab to make sure, are these mistakes or these people, do the Bach people really know what they are doing? These two guys came back to EPRI and said, I have seen this result, this is world class, top class laboratory, these guys know what they are doing, this is real. And because of that, EPRI released the fund to Mike McCubbry. So historically, it played a very important role. But the person who was director of BARC at the time was promoted to chairman of the Indian Atomic Energy Commission. And the next man who took over, he was also a physicist, he was my immediate boss, he took the opposite view of cold fusion. You see, he has, you can imagine, he has just been appointed as director of BARC. US Department of Energy has come to his conclusion cold fusion is nonsense. American Physical Society also said. So he was confused. Many people told him, listen, I don't want to give his name, Dr. So-and-so, you have just been appointed director of BARC. I want to caution you, don't spoil the name of BARC. They're doing good work, but in the world, everybody, the top experts, the American experts have said cold fusion is nonsense. So I would advise you, don't encourage it or give it. So he, in his wisdom, shut down cold fusion. That's the story, but of course he told me personally, listen, you are welcome in your individual capacity, but I will not give you institutional support. So I carried on some of my colleagues, but then I retired and cold fusion fizzled down out of the, so from a position of excellent results, world's biggest group, top class, at ICCF1 when we presented our results, Martin was so excited, he came and congratulated me and whatever we did. So that's the story. So these things happen, many similar things have happened all over the world in every lab. It is the very negative report of the US Department of Energy which has really done the damage. 23 years later, we are still struggling.
So at BARC, initially you had the director was supportive.
Totally. He
But not the whole community.
No. Everybody, listen, those early days, everybody was puzzled, everybody was surprised. But it is a question of whether you have the guts to go and investigate. This particular director, by his nature, he was curious, inquisitive. He was not afraid to do research of spoiling his name. Just try it out with an open mind. If you don't get results, shut it down, no problem. So it's the leadership. One man can make all the difference. Now that one man moved out and the next one man came. He had a different view. Like what's happening in power or so many other fields. So it is unfortunate these things happen. But BARC has the potentiality, had the potentiality to really do excellent work, cooperate with the whole world. Unfortunately, after a while, so after 1995, we didn't publish any papers. I retired in 97. But tomorrow I'm going to present only the work we did in that 7-year period. But it still stands.
Well, you also did work in transmutations.
No, I should now clarify. When we were working those, transmutation was not there. Nobody even expected. The cold fusion was bad enough. Fusion between deuterons was bad enough. To say that these deuterons are interacting with the palladium is even more bizarre. Nobody suspected, nobody expected. So the transmutation story really started a little like Miley, George Miley and many others, Mizuno and others observed. But what I did was I was very interested in the phenomenon. I have been following it. We carried out a review. I was actually invited by Stephen Krivitt to write a review because I had invited him to India in 2008. So he was familiar with my interest in the field. So that is how I ended up writing a review. I have not published original papers in transmutation, but I took the trouble to read all the papers and including Iwamura's work and so on, which was not criticized, it was criticized by the presenter from NRL today. So anyway, these things happen in science, this happen in physics.
What do you think about the transmutations effect? What,
I'm a
what is
great
your
believer.
conclusion of your review?
Of course, I believe. Our paper, which is published by this thing, I'm fully convinced, although all the measurements may not have been to world class, some of them may even have been mistakes, but if you put it all together in a variety of experiments and I'm convinced the phenomena I was introduced to the phenomenon of biological transmutation by Eugene Mellon. He's a good friend of mine, the founder of the Infinite Cold Fusion magazine and so on. So I have looked at all the other papers. So to me, it appears very plausible, and whatever the Kerbrand's book has said sounds reasonably interesting. So although the jury is still out, I think it's definitely taking place, this transmutations part.
What about now? There's been a real resurgence in awareness about this field. Is there more interest in research in India now?
Unfortunately, I think India has missed the boat to enter into basic research until the US Department of Energy changes its mind. I don't think they are going to swing. They need international public, the opinion of the scientific community to continue research in the national laboratories, government. However, I think the world has reached a stage where these new results, whether it is Rossi or Diffcalion or whatever it is, showing these kilowatt levels of heat, has caught the attention of the industry. So I am working with some top corporations, multi-billion-dollar corporations. I've been having discussions. They are showing interest. My own feeling is the tie-up for the industries to take interest will come earlier in India than basic research at this point in time, because we do need power in India.
So you feel that the interest from India has really increased, despite the fact that there really is no commercially viable product as
I
yet.
would say that. No, it's the other way around. It is the claims of commercially viable products. I personally believe it's much more than claims. I do believe that whoever is talking, whether it is Rossi or Diffcalion or other companies, they do have something interesting. One has to follow it up. So it is these claims or potentialities which is industry. I have been in touch with them and I am trying to explain to them to sit up and look at it. So I think in that sense there's a little bit more interest. And
how about academia? Are schools or universities doing any research?
No, and that is what I'm very upset about. They are still, everybody is looking, this is the herd mentality. I'm very sorry that the Indian, because I conducted the 16th International Conference, this is in Chennai. One day the tutorial school I conducted at the Indian Institute of Technology, Madras, hoping, I took a lot of trouble to send personal letters of invitation to the professors, and they didn't turn up, they boycotted. So I am very surprised after, why are these people scared to even attend a meeting? So to answer your question in academia and how much I have been fighting with my former colleagues who are in charge of various conferences, I said, you're having a conference on solid state physics, why don't you have an invited paper? I'll come and tell you what's happening. No cold fusion. So it is very surprising, very sad that I have gone and given lectures in the Nuclear Research Center, in the Bhaba Atomic Research. I have talked to all the top people, since they all know me from those days. It has not, younger people are showing some interest, but it has not got into the research program. Nobody has shown the curiosity or interest to sit up and try out some experiment. Not so far. So, from whatever I see in the last one year or so, the response from industry is much more encouraging to me than the response of the academician.
Are there any applications that you see coming first? For instance, what applications of this reaction?
I would say, for example, there is a lot of shortage of power in India. Many places in India, there are southern parts of India, there are 10 hours power cut, no power. So all these people are buying gensets, diesel gensets, to many new apartment buildings, 6 stories buildings, as routinely purchase a genset and put it in the compound so that the lifts can operate when there is a power cut. So there is a very dire need for captive power sources in the absence of distributed power. So, but that is very expensive. So if somebody can come up with an LNR driven genset, it is going to sell like hotcakes. So I see that as a potentiality. Desalination. In many villages in India, there is no water, groundwater. The villagers have to walk 3 miles or whatever it is to go to a well to collect water. So we need clean drinking water. I would give that as high priority. Village schools don't have lighting at times, no fans, no this. So if you can get power just at low level enough to give lighting, so there is a need. It is these, my own personal interest is to see that when this application comes, I want it to go into the rural area rather than the cities. Cities don't need it. They need for the advertisements or neon lights. That's not what we want. I would like to look at applications which directly go into the villages. So this is what I'm looking at. This is what I'm discussing with people. So let us see how it comes.
All of those applications are scalable from small to large.
Exactly.
How does cold fusion Leonard technology fit into a scalable application?
Listen, from whatever I have seen, we have seen, the typical power level of a basic unit is in the 5 to 10 kilowatt region. So anything more than that, like what Rossi has done, you have to just put multiple units depending on how much you need, how much you can fit in. So obviously there is a trade-off. You cannot put 20,000 units in one module. Chances are there is an obvious upper limit, and you don't need. There's no need for us to send it back into the grid, depending on the requirement and the demand. So you have to make units of that size. So typically maybe a megawatt, 10 megawatts is probably the maximum level. I don't expect LNR to generate a gigawatt. It is ridiculous for us to, where you need it, you make the right amount. I would say megawatt level is probably the few megawatts, but even for a genset, you don't even need that much, even 30 kilowatts, giving 10 kilowatt of electricity, 30 kilowatts thermal, 10 kilowatts of electricity, has an immediate application. It will sell like hotcakes, provided we are able to pass the safety test. Those are issues, especially the word nuclear. These are what is going to delay the market penetration. If we try to avoid using the word nuclear, you can play the game for a while, but sooner or later the authorities will know it is nuclear, so you have to go through the regulatory process. So I think those are the things which will take some more time, but we are jumping the gun. Let us first get the first 30 kilowatt genset working, or the first 1,000 liters. One of my pet projects is to come up with a clean source of drinking water. Now, only if you are in India you will realize what a big problem it is. There are villages, which, as I said, who have to travel drinking water, clean drinking water. I am pursuing what is called the water out of thin air concept. If you have heard of that, you have a cold junction like a refrigerator, water condenses on that and you produce clean water directly. Apparently it was the US Army which first developed this for use in their units, but now even in Chennai there are companies which are manufacturing drinking water. You can go and buy a unit, water out of thin air. You plug it in like a refrigerator. It produces a cold junction, produce water, 10 liters a day, whatever it is. Now imagine one of those. Instead of using electricity, I put in an LNR, source of heat, which you convert into a cold junction using appropriate evaporation. Now all this is commercially available. Once you have a source of heat, you can produce a cold junction, you can connect it to water. So my dream is to get a little, shall we say, a green box in which there is neither electrical power input nor water inlet. It just keeps producing 2000 liters of water a day. You see the effect it will have in the villages in India. The politicians will jump on it. The moment I get one of those made and call a politician, they will buy 1,000 of these to get votes. They will go and put it up in the villages, so that is what I call water or thin air project, and I've already tried it. It turns out a 50 kilowatt thermal matches very well with the typical things, so that you get 1,000 liters of water a day.
Mm-hmm.
Put one of those in each village and all the villages will come and collect the drinking water. So there is a need for a source which is cheap, which is clean. So it appears that the new LNR plus technology may have all these things, but we have to work some more.
So you think a commercial product will be the only thing that will change the federal acceptance of this, regardless of the DOE?
One of these things. If the Department of Energy and American Physical Society reverse their original boycott, that will help. In the absence of such a breakthrough coming through the established scientific community, it is only the industrial product. These guys are denying the truth. When they see units being sold in the market, they will wake up. So we hope both take place, and there is an intense need. From whatever we have seen, very good prospects these things are going to take place, unless there is a totally unexpected problem, and that we have to, let's hope that it works.
So we have NASA working on technology, and we have the Navy working on technology, but they don't really have the influence that the DOE has.
Unfortunately. Well, I think it's the oil industry or whoever it is who is really seeing to it these things don't happen. And it's very sad, but this is the reality. We know the power of the multinational companies to change the course of policy making in all countries. But, in spite of it, there's a good chance LNR will come. If not in the US, somewhere there's a need for it. I expect China or Korea will produce something and sell it in Africa. These guys will still be saying they don't believe in it, but out there in the villages in Africa, you'll be having, then they wake up. Somebody, BBC will go and say, listen, this is what is happening in China produced. So that is what is going to take place.
Well, let me just ask you, what is your favorite word to describe this reaction? What do you like to call it? Because there's many different names.
I know, I think this is, so long as we accept. I don't want to get into that particular, it is irrelevant. Honestly, you call it LENR, LANR, that's not the issue. Show us a working unit. We are all talking about the same thing. I mean, it is almost like different religions. You have one God, you call it, forget it, that's not the issue. Don't even waste your time on finding out which is this, any one of these. But it is nuclear. And in solid state, nuclear reactions are taking place. You call it, you want to call it Fleischmann positive, go ahead. I mean, I think it is exactly the same comparison. Religion, you can call it Allah, you can call it Shiva, you call it Jesus Christ, whatever it is, doesn't matter. But it's a complete waste of time to go along that line.
This is a nuclear reaction. Can you describe why it is a safe nuclear reaction. Why is this technology safe?
Well, when we say safe, we are comparing it to the known nuclear reactions which are used for energy generation, namely fission and perhaps in the long term, as they say, fusion. But both of these are accompanied by radiation, whether it is neutrons, radioactivity. In comparison to that, the amount of radiation produced by this is far, far smaller. But we still are not in a position to say it's zero. There is going to be some, as is evident, we talk about tritium, somebody talks about X-ray. So it is going to be, but maybe comparable to an X-ray machine or other commercial radiation devices. So, but it can be taken care of when there is a need, when they find that this is going to make a change to the overall electrical generation. I think people will learn to live with a small amount of radiation compared to the most important thing is you don't have the radioactive waste. That is, living for 100,000 years, no plutonium, no weapons grade either fissile materials.
Okay, one more question. How will adopting this technology eventually, how will it change the world?
Well, the world needs energy, much more so the developing world. And already there is this concern about the greenhouse gases, the carbon dioxide pollution due to that, the thermal pollution and the heating, the global warming phenomena. So all the known sources have their problems. If this has no emission of greenhouse gases, this has very little radioactivity, and there is a need. So eventually it's the marketplace that is going to like solar energy or non-fossil, so renewable energy. This will eventually have to compete with renewable energy, solar energy versus all the other petrol produced from
fossil fuels?
We're talking about from plants and so on. What do you call that?
Methanol,
biofuels and so
Yes.
on. But all of them have been, even solar energy has been. It's not as if it doesn't have the pollutions, because to produce those cells, the refining the germanium or whatever, all this thing, there is somebody somewhere is releasing gases. So the carbon footprint of the technology has to be established, the cost has to be established, and eventually these are the things which will. So it does appear that LENR is as clean or as safe as renewable, perhaps safer. So that we will know. So that's it. We hope.
Right.
Thank you very
That
much.
was great.
Thank you very much.
You did a great job. See, that's what we need science clean, it's safe, the world needs it. What are all the applications?
Well, I hope I'll have a chance to see what I've said.
Yeah.
Sure.
Yes.
Okay. Thank you very much.
Great.
Absolutely, yeah.